So after watching this video, you should be able to use the trapezoidal rule to find an approximation for the value of the area under a graph. The big thing you'll have to remember is the area of a trapezium. So the area of a trapezium is the average of the two parallel sides, A and B, so added together divided by 2, times by the height of your trapezium. That's the big thing you have to remember because we're calculating area using trapeziums. Alright, so instead of using rectangles, we might get a better approximation for finding the area under a curve using trapeziums. Now, notice here in our example that previously when we had our rectangles, they would come up and out, and those rectangles would give us an answer or a value for area that would be way different to what the actual area under the curve would be. But these trapeziums follow our curve a little more neatly, and so they should give us a better approximation. Now the formula we're going to use for this is this one here, so saying that area is approximately equal to, W over 2, so W is just the width of our trapezium. E is the sum of the end points, or the sum of the y values at the ends, and then plus 2m, m is the sum of all the values in the middle, in between our two endpoints. So basically, it looks a bit like our area formula. It is the average of our two parallel sides. In this case, our parallel sides are going upwards and downwards, so you've got left and right side. The one thing that does look a bit strange is why is there a 2 in this equation? Now, where that comes from basically is that all of the middle sides here are used in two trapeziums. So this middle side is used in the left trapezium and the right. Same for this middle length, it's used in the left and the right. So hence we have to times it by 2 because we're using it twice. The end values up here at A and this end value here, those are only used once, and hence that's why there's no 2 in front of the E term. It's just the endpoints on their own, but we're doubling everything in the middle because we're using those values twice. Alright, so in this example, students, we want to find the area underneath this curve, y equals x squared, between 0 and 5, and we're going to use 5 trapeziums to do so. There's my interval, there's my function, and there's the number of trapeziums I need to use. A good place to start is to work out, well, how wide are my trapeziums going to be, because once we've found the width, we can then work out what x values we need to find the height of each of those trapeziums. So, our width, well, first of all, our interval from 0 to 5, well, that's a width of just 5. And that width of 5, we're splitting into 5 trapeziums, so my width is going to be 5 over 5, or 1 unit. And that will be very handy, because in our next step, I'm going to draw a quick diagram of our interval from 0 to 5, and we're going to go up in my widths of 1. 1, 2, 3, 4. Now what this does is it clearly identifies for me what my end values are, 0 and 5 of my interval, and it shows me as well what values I'm going to need to use to calculate all the middle heights for my function and to really calculate that m value there. So let's give that a go now. So my end values are going to be x equals 0. And so when I substitute x equals 0 into our equation, y equals 0 squared, which is 0. And my other end value is 5. So that makes y equals 5 squared, which is 25. Now, all my m values, I can see on my interval are in between 0 and 5, and there these values are listed here. Now for a width of 1, it's pretty clear what all those values are I'm going to use to substitute in and work out those heights. But when we start talking about maybe widths of 0.6 or 0.8, it might be a good idea to use this diagram to help make sure you're using the right numbers when you're substituting them in. Alright, so now I'm finding my m values. I'll start off with x equals 1, and so y is going to equal 1 squared, which is 1, for my x value of 2. Y equals 2 squared, which is 4, for my x value of 3. Y is going to be 3 squared, which is 9, and for 4, my y value is going to be 4 squared, which is 16. Alright, I've got all my values now. I've got my e values and my m values. What I could do now is I could just add them all up together. That'll make things a little bit easier later. So adding those values up, my e values equal 25. Adding these values up, 1 and 9 is 10, 4 and 16 is 20. So my m values all add up to 30. And now I can use my formula. So my area is going to be approximately equal to W over 2 E plus 2m. It's going to be 1 over 2. My e values are 25 plus 2 times 30. 2 times 30 is 60. 60 plus 25 is 85 over 2, which is 42.5 units. And there's our solution using the trapezoidal method. That will give us a much better approximation for what the actual area under the curve will be, compared to using rectangles. Right, so after watching this video, you should be able to use the trapezoidal rule to determine an approximate value for the area under a curve.